Hello, in this lecture we will find the area of triangle ABC in two different ways. In the drawing we have triangle ABC with side AB that equals to 8 units, side AC of triangle ABC equals to 14 units, and the angle ACB equals to x degrees in size, and angle ABC equals to 2x degrees in size. And first of all we will do a construction. We will draw line segment AD that touches side BC of triangle ABC at point D, and we will draw a line segment AD in such way that the angle ADB will be equal to 2x. Okay, so this angle equals to 2x, okay, and the touching point between the line segment to side BC of triangle ABC is at point D. So angle ADB equals to angle ABD. Both those two angles are equal to 2x degrees. Okay, and we actually have a rule. We'll call it rule number 1. Rule number 1 states that in front of equal angles in the triangle there are equal sides. Okay, in front of equal angles in the triangle there are equal sides. So I will read rule number 1 again. Rule number 1 states that in front of equal angles in the triangle there are equal sides. So actually, if we have triangle ABC with two equal angles, so this angle is angle alpha, and this angle is also angle alpha. According to rule number 1, in front of this angle alpha we have side AB, and in front of this angle alpha we have side AC of triangle ABC. According to rule number 1, the sides that are in front of the equal angles are also equal between each other. So AB is also equals to AC. Again, according to rule number 1, the sides that are in front of the equal angles are also equal between them. The side that is in front of this angle is AB, and the side that is in front of this angle is AC. According to rule number 1, the sides are also equal between them. That is to say, AB equals to AC. Okay? So we actually can implement rule number 1 in our drawing. We have triangle ABD. This triangle ABD has two equal angles. Okay, actually the green triangle ABD has two equal angles. The green triangle ABD has two equal angles. Those two angles are equal between them. Both of them are equal to 2x. And therefore, according to rule number 1, the side that is in front of this angle is AB, and the side that is in front of this angle is AD. And according to rule number 1, the sides that are in front of equal angles are also equal between them. That is to say, AB equals to AD. Okay, according to rule number 1, AB equals to AD. Rule number 1. Okay, according to rule number 1, AB equals to AD. But we know that AB equals to 8 units. It is given us in the question that AB equals to 8 units. So from this equality, we can deduce that AD also equals to 8 units. Okay, AD also equals to 8 units. So AD equals to 8 units. Okay. And we have also rule number 2. But before I will mention to you, before I will explain what is rule number 2, before I present rule number 2, I will explain you what is exterior angle and what is the definition of interior angle. So actually, if we have triangle ABC, that can be any triangle, actually angles alpha, beta and gamma are defined as interior angles. They are interior angles because they are inside the triangle ABC. Interior angles. And the angle ABL, this angle is defined as exterior angle. It is exterior angle. And in relation to angle gamma, angle alpha and beta are located in the opposite side of in relation to angle gamma, so they are also defined as opposite interior angles. Okay, so those two angles alpha and beta are opposite interior angles in relation to angle gamma. They are located in the opposite side, so they are opposite interior angles. And angle ABL, this angle is defined as exterior angle. Okay, so rule number 2 states that the exterior angle of a triangle is equal to the sum of the two opposite interior angles. So I will read rule number 2 again. Rule number 2 states that the exterior angle of a triangle is equal to the sum of the two opposite interior angles. Okay, so actually, according to rule number 2, the exterior angle ABL is equal to the sum of the two opposite interior angles. That is to say, angle ABL equals to angle alpha plus angle beta. Okay, so according to rule number 2, the exterior angle ABL equals to the sum of the two opposite interior angles that are actually angles alpha and beta. So it equals to angle alpha plus angle beta. Okay, so the exterior angle ABL equals to the sum of the two opposite interior angles. That is to say, angle ABL equals to angle alpha plus beta. Again, angle ABL, the exterior angle ABL, equals to the sum of the two opposite interior angles. So it equals to angle alpha plus angle beta. Okay, so we actually again can implement rule number 2 in our drawing. We have triangle ADC the orange triangle ADC, okay, so we relate to the orange triangle ADC, so in the orange triangle ADC, we have two opposite interior angles. Actually, in the orange triangle ADC, we have two opposite interior angles, angle DAC and angle ACD are defined as opposite interior angles. So those two angles are defined opposite interior angles in relation to this angle. They are defined as opposite interior angles, and angle ADB in the green triangle is defined as exterior angle. Angle ADB that equals to 2x are defined as exterior angle. Okay, so in the orange triangle ADC, angles DAC and angle ACD are defined as opposite interior angles, while angle ADB that equals to 2x are defined as exterior angle. This angle that equals to 2x are defined as exterior angle. According to rule number 2, the exterior angle ADB that equals to 2x, it also equals to the sum of the two opposite interior angles. That is to say, it equals to angle DAC plus angle ACD. Again, according to rule number 2, the exterior angle that equals to 2x, this angle, is equal to the sum of the two opposite interior angles. That is to say, it equals to this angle plus this angle. It equals to angle DAC plus angle ACD, according to rule number 2. Okay, but what is the value of angle ACD? The value of angle ACD equals to x. So here we can substitute angle ACD by x because it is equals to x. Okay, so angle DAC plus x equals to 2x. So we got the equality that states that 2x equals to angle DAC plus x. Okay, so here we can subtract x from this equality and we will get that angle DAC equals to x. Okay, we found out that angle DAC equals to x. So actually this angle DAC equals to x. So actually in the orange triangle, in triangle ADC, we have two equal angles. Those two angles are equal to each other. They are equal to x degrees in size. So in triangle ADC, we have two equal angles. Okay, in the green and in the orange triangle ADC, we have two equal angles. Okay, in the orange triangle ADC, we have two equal angles, and according to rule number 1 that states that in front of equal angles in the triangle there are equal sides, then in front of this angle x we have side DC, and in front of this angle we have side AD. And according to rule number 1, the sides that are in front of equal angles are also equal between them. That is to say, AD equals to DC. Okay, AD equals to DC. Rule number 1 states that in front of equal angles we have equal sides. In front of this angle we have side DC, and in front of this angle we have side AD. And according to rule number 1, the sides that are in front of equal angles are also equal between them. That is to say, AD equals to DC. AD equals to DC according to rule number 1. According to rule number 1, AD equals to DC. Okay, but we know, we have already found out that AD equals to 8 units. AD equals to 8 units. AD equals to 8 units. So from this equality, we can deduce that DC also equals to 8 units. Okay, DC also equals to 8 units. Okay, DC equals to 8 units, so we can write here that DC equals to 8 units. Okay, we have also rule number 3. Before I present to you rule number 3, I will explain to you what is the base of an isosceles triangle. If we have triangle ABC that is an isosceles triangle, So if triangle ABC is an isosceles triangle, that is to say, it has two sides that are equal between them. That is to say, AB equals to AC, AB equals to AC, then the base of triangle ABC is BC. The base of triangle ABC is BC. Okay, BC is the base of triangle ABC. Now I will present to you rule number 3. Rule number 3 states that the height to the base in an isosceles triangle divides the base to two equal parts. I will read rule number 3 again. Rule number 3 states that the height to the base in an isosceles triangle divides the base to two equal parts. So actually, if we have this isosceles triangle, triangle ABC, and we will draw height to the base from point A. The height always creates 90 degrees with the base, that is to say, we will define the touching point between the height to the base BC as point D. As I've already mentioned, the height always creates 90 degrees with the base BC, that is to say, AD creates 90 degrees with BC, that is to say, this angle is 90 degrees, and this angle is 90 degrees. So, according to rule number 3, the height to the base in an isosceles triangle ABC divides the base BC to two equal parts. That is to say, BD equals to DC. Okay, so BD equals to DC. That is actually rule number 3. Again, if we have isosceles triangle, triangle ABC, and we draw height, that is the height, the red straight line is the height to the base, and the height to the base always creates 90 degrees with the base. This is 90 degrees, and this angle is equals to 90 degrees. The height to the base, according to rule number 3, divides the base BC to two equal parts. That is to say, BD equals to DC. Okay? So, again, we can actually implement Rule number 3, in our green triangle, the green triangle, triangle ABD, the green triangle, triangle ABD, is an isosceles triangle because side AB of the triangle ABD equals to side AD. AB equals to AD. For that reason, the green triangle, triangle ABD, is an isosceles triangle. So according to rule number 3, if we draw height from point A to the base BD, so the height first of all, the height creates 90 degrees with the base, therefore this angle is a right angle and this angle is also a right angle, and we will call to the touching point between the height to the base BD point E, and according to rule number 3, the height, so we will call also to the height H, this is abbreviation for height, so the height to the base BD divides the base BD to two equal parts, that is to say BE equals to ED. Okay, so according to rule number 3, in the isosceles triangle, the green isosceles triangle, triangle ABD, the height AE divides the base BD to two equal parts, that is to say BE equals to ED. According to rule number 3, BE equals to ED. That is according to rule number 3. Okay, again, according to rule number 3, the height divides the base to two equal parts, that is to say BE equals to ED. Okay, and we will define BE as A, that is to say BE equals to A, BE equals to A, BE equals to A. So from this equality we can deduce that ED also equals to A, ED equals also to A, okay, ED also equals to A, so actually triangle ABE, that is the half of the green triangle, the half of the green triangle, triangle ABE, is a right triangle because it has angle AEB that equals to 90 degrees. Okay, angle AEB in triangle ABE, angle AEB equals to 90 degrees, angle AEB equals to 90 degrees. Okay, again, in the half green triangle, triangle ABE, angle AEB equals to 90 degrees. Therefore, triangle ABE is a right triangle. Therefore, triangle ABE is a right triangle. This triangle ABE, is a right triangle. Therefore, we can implement the Pythagoras theorem in the right triangle ABE. According to the Pythagorean theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, AB square will be equal to BE square plus AE square. Okay, so according to the Pythagorean theorem, in the right triangle ABE, the square of the hypotenuse, that is AB square, equals to BE square plus AE square. But what is the value of AB? AB equals to 8 units. It is given us in the question. So AB square is 8 square and 8 square is 64, equals to BE square. BE equals to A, so BE square is A square plus AE square. AE equals to H according to our definition, so AE square is H square. So equation number 1 states that 64 equals to A square plus H square. Here in this equation number 1, we will subtract A square from equation number 1, and we will get that H square equals to 64 minus A square. Okay, H square equals to 64 minus A square. Okay, and then we actually also have triangle AEB, triangle AEC. This triangle is also a right triangle because angle AEC is a right angle. So I write it down. Triangle AEC is a right triangle because angle AEC is a right angle. Again, triangle AEC is a right triangle because angle AEC is a right angle. therefore, we can implement the Pythagorean theorem in the right triangle AEC, and according to the Pythagorean theorem, in the right triangle AEC, the square of the hypotenuse, that is AC square, equals to the sum of the squares of the perpendiculars, equals to AE square plus EC square. Okay, that is according to the Pythagorean theorem. Again, according to the Pythagorean theorem, in the right triangle AEC, the square of the hypotenuse, that is AC square, equals to the sum of the squares of the perpendiculars, that is to say it equals to AE square plus EC square. Okay, but what is the value of AC? AC equals to 14 units. It is given us in the question, so AC square equals to 196 equals to AE square. AE equals to 8 according to our definition, so AE square equals to 8 square plus EC square. EC equals to A plus 8. Again, EC equals to A plus 8. So EC square equals to A plus 8 square. So equation number 2 states that 196 equals to 8 square plus A plus 8 square. But we have already found out in equation number 1 that 8 square equals to 64 minus 8 square. So we can substitute 8 square by 64 minus 8 square, because 8 square equals to 64 minus 8 square. Okay, so we will do it now. We will get that 196 equals to 8 square is 64 minus 8 square, according to equation number 1, plus A plus 8 square. A plus 8 square equals to A square plus 8 square, that is 64, plus 2 times A times 8, that is 16A. So in total we got that 196 equals to 64 minus A square plus A square is 0. So A square is cancelled, plus 64 plus 16A. So here 64 plus 64 is 128. So I will write it down. You will get that 196 equals to 128 plus 16A. Okay. Equation number 2 states that 196 equals to 128 plus 16A. Here we will subtract 128 from equation number 2, and we will get that 16A equals to 196 minus 128 is 68. So we got that 16A equals to 68. Here we will divide the equation number 2 by 16 in order to get the value of A. We will get that the value of A is actually 68 over 16. 68 over 16, we can divide the numerator and the denominator by 4. 68 over 4 is 17, and 16 over 4 is 4. So in total we will get that is 17 over 4. A equals to 17 over 4 units. Okay, we found out that A equals to 17 over 4 units. So I write it here that A equals to 17 over 4 units. But equation number 1 states that h squared equals to 64 minus a squared. According to equation number 1, h squared equals to 64 minus a squared. So here we will square this equality in order to get the value of a squared. A squared will be equal to 17 squared is 289 over 4 squared is 16. So we got that the value of a squared is actually 289 over 16. So we can substitute a squared in equation number 1 by 289 over 16. We will get that h squared equals to 64 minus 289 over 16. So here we will multiply 64 by 16 and then we will divide it by 16 in order to have common factor with this number. Okay, so h squared equals to 64 times 16 is 1024 over 16 minus 289. So we got that the value of h squared is 1024 minus 289 over 16. 1024 minus 289 is actually equals to 735 over 16. So we found out that the value of h squared is 735 minus 16. Here we will take a root out of this equality in order to find out the value of h. And we will find that the value of h is actually equals to the root of 735 over 16. But 735 equals to 15 times 7 times 7, and 16 equals to 4 times 4. So actually here the root of 7 times 7 is 7 and the root of 4 times 4 is 4. So we can take out 7 over 4 from the root and we will get that h equals to 7 over 4 is taken out of the root, and inside the root what is left is only 15. So actually we found out that the height of triangle ABC is 7 over 4 times root 15 units. Actually, I said that is the height of triangle ABC, although we draw height to triangle ABD because the height edge creates 90 degrees not only with side BD but also with side BC of triangle ABC, because BD and BC are located on the same straight line. So the height of triangle BD is also the height of triangle ABC. The height of triangle ABD is also the height of triangle ABC because BD and BC are located on the same straight line. So this angle creates 90 degrees not only with BD but also with BC. Okay, and this angle also creates 90 degrees not only with side BC of triangle ABD but also with side ABC of triangle ABC, with side BC of triangle ABC, because BD and BC are located on the same straight line. Okay, so we found that the height of triangle ABC is 7/4 times root 15, and we have already found out 7/4 times root 15 units, and A equals to 17/4 units. Okay, so we actually have all the data in order to find out the area of triangle ABC. We know what is the value of A is 17/4 units, and the height, I again emphasize that the height edge is the height of triangle ABC also. So we know the height of triangle ABC and we know the value of the base, because we found out that A equals to 17/4. So the only thing that is left is to find out the area of triangle ABC that is equal the area of any triangle. A is the abbreviation for area, equals to the base of the triangle times the height to the base over 2. Okay, the formula for the area of any triangle equals to the base of the triangle times the height to the base over 2. And I should emphasize that the height to the base must create 90 degrees with the base. And as you can see here, the height edge indeed creates 90 degrees with the base BC, because this angle is a right angle, this angle is also a right angle. So the height AE, that is edge, creates 90 degrees with the base BC. Therefore, edge is indeed the height of triangle ABC. Okay, so the area of triangle ABC equals to the base of the triangle ABC, that is BC, times the height to the base, that is H. We have already found out that H equals to 7/4 times root 15 units, and we have already found out that A equals to 17/4 units. So we have all the data that is needed in order to find out the area of triangle ABC. So it is the base is BC, the height is H over 2. So the area of triangle ABC equals to the base, that is BC, times the height, that is H, over 2. But what is the value of BC? The value of BC is actually A plus 8, or the value of side BC of triangle ABC, that is the base of triangle ABC, equals to 2a plus 8. 2a plus 8 times the height times age. We have already found out that age equals to 7 over 4 times root 15 units, all divided by 2. So the area of triangle ABC equals to 2 times a plus 8 times 7 over 4 times root 15 over 2. We have already found out that a equals to 17 over 4 units. So we have all the data in order to find out the area. We will substitute a by 17 over 4 units. So the area of triangle ABC will be equal 2 times a is 2 times 17 over 4 equals to 17 over 2 plus 8 times 7 over 4 times root 15 over 2. So the area of triangle ABC equals to 17 over 2 plus 8 times 7 over 4 times root 15 over 2. Here 4 times 2 is 8, and here we will substitute 8 by 16 over 2 in order to have a common factor with this number, and we will find that the area of triangle ABC equals to 17 over 2 plus 16 over 2 times 7 over 4 times 7, and 4 times 2 is 8 times root 15. So in total we found that the area of triangle ABC equals to 17 plus 16 over 2 plus 7 times root 15 over 8. 2 times 8 is 16, and 17 plus 16 is 33. So I write it down. So the area of triangle ABC equals to 33 times 7 times root 15 over 16. So the area of triangle ABC equals to 33 times 7 times root 15 over 16. 33 times 7 is 231. So I write it down. So the final answer is that the area of triangle ABC equals to 231 times root 15 over 16 square units. The area of triangle ABC equals to 231 times root 15 over 16 square units. Okay. The area of this triangle equals to 231 times root 15 over 16 square units. So that was first method to find out the area of triangle ABC. In the next step I will present to you second method to find out the area of triangle ABC. So first of all, we will find the size of angle A. We know that in any triangle, the sum of the angles in any triangle equals to 180 degrees. So angle A plus angle B plus angle C must be equal to 180 degrees, okay? So the first equality is that angle A plus angle B plus angle C equals to 180 degrees. Okay? The sum of the angles in any triangle equals to 180 degrees. So angle A plus angle B equals to 2x. Angle B equals to 2x, so we can substitute B by 2x. And angle C equals to x, so we substitute C, angle C by x. So in total we got that angle A plus x plus 2x plus 2x plus x equals to 180 degrees. 2x plus x is 3x. So I write it down. We got that angle A plus 3x equals to 180 degrees. So here we will subtract 3x from this equality in order to get the value of angle A. We will get that the value of angle A equals to 180 degrees minus 3x. So we found out that the value of angle A is 180 degrees minus 3x. Okay, so we can write here that angle A equals to 180 degrees minus 3x. Okay, angle A equals to 180 degrees minus 3x. In the next step, I will present to you a new rule, rule number 4. In rule number 4, I will present a new formula for the area of any triangle. Okay, so rule number 4. Is actually a new formula for the area of any triangle. So if we have triangle ABC that is not necessarily our triangle but can be any triangle, any other triangle, and we know that side AB of triangle ABC equals to A units in size, and side AC of triangle ABC equals to B units in size, and the angle between side AB and side AC of triangle ABC is theta. Then, according to the rule number 4, the area of this triangle ABC will be equal area of triangle ABC equals to A times B times sinus theta times sine theta over 2. We can use it in any triangle to find out the area of the triangle. The new formula for the area of any triangle is the area equals to A times B times sinus theta, that is the angle between side AB and side AC of the triangle, over 2. And again, we can implement rule number 4 in our triangle. We will calculate the area of our triangle ABC, according to the new formula. So according to the new formula, the area A is the abbreviation for area of our triangle ABC, will be equal to AB times AC times sine 180 degrees minus 3x over 2. Again, the area of our triangle ABC, according to the new formula that I mentioned in rule number 4, the area of our triangle will be equal to AB times AC times sine of 180 degrees minus 3x over 2. But what is the value of AB? The value of AB is 8 units. The value of AC is 14 units. And we have also sine of 180 degrees minus 3x, all divided by 2. Okay, so the area of triangle ABC, our triangle, equals to 8 times 14 times sine 180 degrees minus 3x over 2. Here 14 times 2 is 7, and 8 times 7 is 56, so I will write it down. We will get that the area of triangle ABC equals to 56 times sine of 180 degrees minus 3x. Okay, the area of triangle ABC equals to 56 times sine of 180 degrees minus 3x. Now we have a trigonometric identity that states that the sine of 180 degrees minus alpha equals to sine alpha. We can use this trigonometric identity, and we can say that sine of 180 degrees minus 3x equals to sine 3x. Okay, so this is actually equation number 1 that states that the area of triangle ABC equals to 56 times sine, and instead of 180 degrees we can write, instead of 180 degrees minus 3x, we can write 3x according to this trigonometric identity. So in total we got that the area of triangle ABC equals to 56 times sine 3x. Okay, so in the next step I will present to you a new rule that is actually the law of sines, and we will use the law of sines in our triangle. So rule number 4, rule number 5 is the law of sines. The law of sines So if we have, first of all, I must emphasize that the law of sines can be used in any triangle. It is valid in any triangle. So especially we can use it in our triangle, triangle ABC. So in any triangle, if we have triangle ABC, that can be any triangle, not necessarily our triangle ABC, but any other triangle. So if we have this triangle, triangle ABC, and we know that side BC of triangle ABC is A units in size, side AC of triangle ABC is B units in size, and side AB of triangle ABC is C units in size. And so according to the law of sines, the following relationship exists between the angles of the triangle to its sides. According to the law of sines, A over sinus A over A over sine A equals to B over sine B equals to C over sine C. So here in this formula, capital A, capital B, and capital C are the sizes of the angles of the triangle. So capital A is the size of this angle, capital B is the size of this angle, and capital C is the size of this angle. Okay, so according to the law of sines, A over sinus A equals to B over sine B equals to C over sine C. Okay, so again, we can implement the law of sines in our triangle ABC. So according to the law of sines, in our triangle ABC, AB over sine X equals to AC over sine 2x. Okay, so according to the law of sines, the implementation of the law of sines in our triangle ABC means that AB over sine x equals to AC over sine 2x. But what is the value of AB? AB equals to 8 units. This is given us in the question. So 8 over sine x equals to AC. What is the value of AC? AC equals to 14 units over sine 2x. Okay, so we found out that 8 over sine x equals to 14 over sine 2x. Here we have trigonometric identity for the value of sine 2x. According to the trigonometric identity, the value of sine 2x is actually equals to 2 sine x cosine x. 2 sine x cosine x. So we actually can substitute sine x by this expression, because sine x, we can substitute sine 2x in this equality by this expression, because sine 2x equals to 2 sine x cosine x. Okay, so we'll do it now. 8 over sine x equals to 14 over, instead of sine 2x, we'll write down 2 sine x cosine x. So here we can cancel sine x, because we have sine x in the denominator of this side of the equation. We have sine x on the denominator of the other side of the equation, so we can cancel sine x, and 14 over 2 is 7. So in total we will get that 7 over cosine x equals to 8. So we got that 7 over cosine x equals to 8. Here we will multiply this equality by cosine x, and then we will divide it by 8, and we'll get that cosine x equals to 7 over 8. Okay, so we got that cosine x equals to 7 over 8. So in the next step, I will present to you trigonometric identity, and from the trigonometric identity we will find out the value of sine x. So the trigonometric identity is that sine square x plus cosine square x equals to 1. Okay, the trigonometric identity states that sine square x plus cosine square x equals to 1. From this trigonometric identity we will subtract cosine square x, and we will get that sine square x equals to 1 minus cosine square x. Here we will take a root out of this equality, and we will find that the value of sine x equals to the root of 1 minus cosine square x. Okay, and the value of sine x is the root of 1 minus cosine square x. But we have already found out that cosine square x, cosine x equals to 7 over 8. So we will square this equality in order to find out the value of cosine square x. So cosine square x equals to 7 square is 49 over 8 square is 64. So we can substitute cosine square x by 49 over 64, because cosine square x equals to 49 over 64. So we will get that sine x equals to the root of 1 minus cosine square x, that equals to 49 over 64. So we got that sine x equals to the root of 1 minus 49 over 64. So here I will substitute 1 by 64 over 64 in order to have a common factor with this number. We get that sine x equals to the root of 64 minus 49 over 64. So here 64 minus 49 is 15. So we will get the value of sine x. It will be equal to the root of 15, and the root of 64 is 8. So we found out that the value of sine x is root 15 over 8. So in the next step we will return to our first equation. According to our first equation, the area of triangle ABC equals to 56 times sine of 3x. Okay? According to equation number 1, the area of triangle ABC equals to 56 times sine 3x. Here I will present to you a new trigonometric identity for the value of sine 3x. The value of sine 3x, according to the following trigonometric identity, is 3 sine x minus 4 sine cube x. Okay, sine 3x equals to 3 sine x minus 4 sine cube x. So we will substitute sine 3x by this expression that equals to sine 3x, and we will get that the area of triangle ABC equals to 56 times, instead of 3 sine x, we will write 3 sine x minus 4 sine cube x. Okay, so the area of triangle ABC equals to 56 times 3 sine x minus 4 sine cube x. Here we will take sine x as a common factor of this expression. We will take out sine x as a common factor of this expression, and we will get that the area of triangle ABC equals to 56 times sine x is a common factor, and inside the brackets we will have 3 minus 4 times sine square x. Okay, so we have this equality, but we have already found out that sine x equals to root 15 over 8. Sine x equals to root 15 over 8. And we will square this equality in order to find out the value of sine square x. Sine square x will be equal to root 15 times root 15 is 15, and 8 square is 64. So sine square x equals to 15 over 64. So the only thing that is left is to substitute sine x by root 15 over 8, and to substitute sine square x by 15 over 64. Okay, so we will do it now. We will get that the area of triangle ABC equals to 56 times sine x equals to root 15 over 8, times 3 minus 4 times sine square x equals to 15 over 64. So in total we got that the area of triangle ABC equals to 56 times root 15 over 8 times 3 minus 4 times 15 over 64. Here 56 over 8 is 7, and here we can divide 64 by 4, and we will cancel the 4, and 64 by 4 is 16, and here we will cancel the 4. Okay, so we divided this expression by 4. Okay, so we will get that the area of triangle ABC equals to 56 over 8 is 7 times root 15, 3 minus 15 over 16. Okay, so the area of triangle ABC equals to 7 times root 15 times 3 minus 15 over 16. Here we will substitute 3 by 84 over 16 in order to have a common factor with this number, and we will get that the area of triangle ABC equals to root 15 times 7. Here is 84 minus 15 over 16. Okay, so the area of triangle ABC equals to root 15 times 7 times 48 minus 15 over 16. 48 minus 15 is 33. Okay, so I write it down. The area of triangle ABC equals to root 15 times 7 times 48 minus 15 is 33 over 16. Okay, so the area of triangle ABC equals to root 15 times 7 times 33 over 16. 7 times 33 is 231, so I write it down. So the final answer to the question is that the area of triangle ABC equals to 231 times root 15 over 16 square units. Okay, so we found out that the area of triangle ABC equals to 231 times root 15 over 16 square units. Okay, so now I will summarize the lecture. We actually wanted to find out the area of triangle ABC. We found out the area of triangle ABC in two different ways. In the first method, first of all, we know that AB equals to 8 units, AC equals to 14 units, and we also know that angle ACB equals to x degrees in size, angle ABC equals to 2x degrees in size, and we want to find out the area of triangle ABC. Okay. So first of all, we made a construction line segment. We draw line segment AD in such a way that angle ADB equals to 2x degrees in size, like this angle ABC, and actually triangle ABD has two angles that are equal to each other, and we actually have a rule that is about a triangle that has two equal angles. According to rule number 1, in front of equal angles in the triangle, there are equal sides. So if we have triangle ABC that has two angles that are equal to each other, here triangle ABC has two angles that are equal to each other, both of them are equals to alpha. So according to rule number 1, in front of equal angles there is equal side. So in front of this angle alpha we have side AC, and in front of this angle alpha we have side AB. So according to rule number 1, the sides that are in front of the equal angles are also equal between them. That is to say, AB equals to AC. Okay, so we can actually implement rule number 1 in our main triangle ABD, because triangle ABD has two equal angles. Both of those two angles are equal to 2x. So according to rule number 1, in front of equal angles we have equal sides. This angle is in front of side AD of triangle ADB, and this angle is in front of side AB. So according to rule number 1, AD equals to AB. Okay, according to rule number 1, AD equals to AB. But we know that AB equals to 8 units. It is given us in the question. AB equals to 8 units. So from this equality we can deduce that AD also equals to 8 units. Okay, AD equals to 8 units. So AD equals to 8 units in size. And then I presented to you rule number 2 that talks about interior angles and exterior angles. In this triangle ABC, those two angles alpha and beta are opposite interior angles, and this angle ABL is exterior angle. And according to rule number 2, the exterior angle of a triangle is equal to the sum of the two opposite interior angles. Okay, so according to rule number 1, the exterior angle ABL equals to the opposite interior angles. That is to say, angle ABL, the exterior angle ABL equals to angle alpha plus beta. Okay, angle ABL equals to alpha plus beta. The exterior angle equals to the sum of the two opposite interior angles. So angle ABL equals to alpha plus beta. And again, we can implement rule number 2 in our drawing, because we have the orange triangle, that is triangle ADC, it has two opposite interior angles, and this angle ADB that equals to 2x is the exterior angle in relation to triangle ADC, the orange triangle. So according to rule number 2, this exterior angle that equals to 2x equals to the sum of those two angles, equals to angle DAC plus angle ACD. Okay, so according to rule number 2, the exterior angle that equals to 2x equals to angle DAC plus angle ACD. But we know that angle ACD, this angle equals to x. It is given us in the question, so we can substitute angle ACD by x. And we'll get this equality that 2x equals to angle DAC plus x. So here we will subtract x from this equality, and we will get that angle DAC equals to x. So this angle equals to x. So in the orange triangle ADC, we have two angles that are equal to each other. Both those two angles equals to x. So according to rule number 1, that states that in front of equal angles there are equal sides. In front of this angle we have side DC, and in front of this angle we have side AD. So according to rule number 1, AD equals to DC. Okay, according to rule number 1, in the orange triangle, AD equals to DC. But we know that AD equals to 8 units. AD equals to 8 units in size, so from this equality we can deduce that DC also equals to 8 units. Okay, DC equals to 8 units. Okay, and we have rule number 3 that states that the height to the base in an isosceles triangle divides the base to two equal parts. So if we have a isosceles triangle ABC, that is to say AB equals to AC, and we will draw height to the base BC, this height AD will divide the base BC to two equal parts, that is to say AB equals to that is to say BD equals to DC. If we draw height from point A to the base BC of triangle ABC, then the height AD will divide the base BC to two equal parts, that is to say BD equals to DC. Okay, so we actually can implement rule number 3 in our triangle, the green triangle ABD, that is isosceles triangle, because AB equals to AD. Therefore, the green triangle is an isosceles triangle. So if we draw height to the base BD, the height will divide the base BD to two equal parts, that is to say BE equals to ED. Okay, BE equals to ED according to rule number 3. When we draw height to the base of isosceles triangle, then the base will be divided to two equal parts, that is to say BE equals to ED. And then we define BE as A, that is to say BE equals to A, and from this equality we can derive that ED also equals to A. So BE equals to A and ED also equals to A. And then actually we have triangle ABE, that is a right triangle because it has angle AEB, that is a right angle. Therefore the half green triangle AEB is a right triangle, so we can implement the Pythagoras theorem in the right triangle AEB. According to the Pythagorean theorem, the square of the hypotenuse is equal to the sum of the squares of the perpendiculars. that is to say AB square equals to BE square plus AE square. Okay, so in the right triangle ABE, AB square equals to BE square plus AE square, according to the Pythagorean theorem. But we know that AB equals to 8 units, so AB square is 8 square equals to 64, and BE equals to A according to our definition, so BE square is A square, and AE equals to H. AE equals to H according to our definition, so AE square equals to H square. So from this equation number 1, we got that H square equals to 64 minus A square. And then we have triangle AEC, that is also a right triangle because angle AEC is a right angle, therefore triangle AEC is a right triangle, so we can implement the Pythagorean theorem in the right triangle, triangle AEC. And according to the Pythagorean theorem, the square of the hypotenuse, that is to say AC square, equals to the sum of the squares of the perpendiculars, equals to AE square plus EC square. Okay, according to the Pythagorean theorem, AC square equals to AE square plus EC square. But we know that AC equals to 14 units, so AC square is 196, AE equals to 8, so AE square is 8 square, and EC equals to A plus 8, so EC square equals to A plus 8 square. So in total we got that 196 equals to 8 square plus A plus 8 square. But we have already found out that 8 square equals to 64 minus A square. So we can substitute 8 square in equation number 2 by 64 minus A square. Okay, we substituted 8 square by 64 minus A square. We have only one variable that is missing, that is A, and we found out by solving this equation that A equals to 17 over 4 units. Okay, and then we have equation number 1 that states that H square equals to 64 minus A square. And we know that A equals to 17 over 4, so if we square this equality, we will get the value of A square, that is actually 289 over 16, so we can substitute A square in this equation by 289 over 16. We substituted A square by 289 over 16, and we got the value of H. We found out that the value of H is 7 over 4 times root 15 units, and we have already found out that A equals to 17 over 4 units. And we know that the area of any triangle is actually equals to the base of the triangle times the height to the base over 2. And the base of triangle ABC is BC, the height is H, AE, that is H, so it is the base BC times the height, that is H over 2, but BC equals to A plus 8, so it is BC equals to 2A plus 8. BC equals to 2A plus 8, and H, we have already found out that H equals to 7 over 4 times root 15 units, so we can substitute H by 7 over 4 times root 15 units, and we have already found out that A equals to 17 over 4 units, so we can substitute also A by 17 over 4 units. Okay, and we found out that the area of triangle ABC equals to 231 times root 15 over 16 square units. So that was the first method to find out the area of triangle ABC. Then we found out the area of triangle ABC according to the second method. In this method, first of all, we found the size of angle A. We know that the sum of the angles in any triangle equals to 180 degrees, and especially in this triangle, angle A plus angle B plus angle C equals to 180 degrees. Okay, angle A plus angle B plus angle C equals to 180 degrees. but we know that angle B equals to 2x and angle C equals to x. So we have this equality that a plus 2x plus x equals 180 degrees, and we found that angle A equals to 180 degrees minus 3x. After we found the value of angle A, we used rule number 4, that is actually I presented to you a new formula to find out the area of any triangle. According to this formula, the area of any triangle equals to A times B times sinus theta over 2. Okay, the area of this triangle equals to A times B times sin theta over 2. And we use this equality, this formula, in order to find out the area of our triangle, triangle ABC. The area of this triangle equals to AB times AC times sinus 180 degrees minus 3x over 2. The area of our triangle, triangle ABC, according to the new formula for the area of any triangle, equals to AB times AC times sin 180 degrees minus 3. And we know that AB equals to 8 units, AC equals to 14 units. Okay, AB equals to 8 units, AC equals to 14 units. So we found out that the area of triangle ABC equals to 56 times sin 180 degrees minus 3x. And we have the trigonometric identity that states that sin 180 degrees minus alpha equals to sin alpha. So the area of triangle ABC equals to 56 times, instead of sin 180 degrees minus 3x, we can write sin 3x because it is equals to sin 3x according to this trigonometric identity. Okay, so we found out that the area of triangle ABC equals to 56 times sin 3x. That is equation number 1. And then I presented to you new rule number 5. That is actually the law of sines. According to the law of sines, A over sine A equals to B over sine B equals to C over sine C. Okay, according to the law of sines, A over sine A equals to B over sine B equals to C over sine B, when capital A, capital B, and capital C are the sizes of the angles. Capital A is the size of this angle, capital B is the size of this angle, and capital C is the size of this angle. Okay, so we can implement the law of sines in our triangle. According to the law of sines in our triangle, AB over sine x equals to AC over sine 2x. Okay, AB over sine x equals to AC over sine 2x. Okay, and we know that AB equals to 8 units and AC equals to 14 units. Okay, AB equals to 8 units, AC equals to AB equals to 8 units, AC equals to 14 units. And here sine 2x equals to 2 sine x cosinus x. So we can substitute sine 2x by 2 sine x cosine x. And here we divided the equality by sine x. Sine x is cancelled. And we got that cosine x equals to 7 over 8. And we have the trigonometric identity that states that sine square x plus cosine square x equals to 1. For this trigonometric identity, we got that sine x equals to the root of 1 minus cosine square x. And we know that cosine x equals to 7 over 8. So if we will square this equality, we will get the value of cosine square x, that is actually equals to 49 over 64. So we can substitute cosine square x in this equality by 49 over 64. Okay, so we found out that sine x equals to root 15 over 8. And then we returned to the first equality, equation number 1, that states that the area of triangle ABC equals to 56 times sine x times sine 3x. And we have the trigonometric identity for sine 3x. Sine 3x equals to 3 sine x minus 4 sine cube x. So we substituted sine x by this expression, and we found out, and then we took sine x as a common factor of this equation, and we know that sine x equals to root 15 over 8, so if we square sine x, we'll get the value of sine square x, and the only thing that is left is to substitute sine x by root 15 over 8, and to substitute sine square x by 15 over 64, and we will get the area of the triangle ABC. So we did it, and we found out that the area of triangle ABC equals to 231 times root 15 over 16 square units, exactly the same result as we found in the first method. Okay, thank you very much.